So now what we're going to be doing is we're going to be simplifying again, but now we're going to do it with more than one base, so kind of with two bases. So we're going to simplify now, but with more than one base. And this is actually not that tricky. We're doing more of the same. I totally forget what example I'm on. I think I'm on 15. Seems like I'm on 15. So let's say we have root x times cube root of y times fifth root of x times fourth root of y. So what we do, we go through our usual shenanigans. We turn everything into exponents. That has the invisible 2 there, so x to the 1/2, y to the 1/3, x to the 1/5, y to the 1/4. Then we're going to kind of push the like terms together. Not really like terms, but x to the 1/2, the same bases. So the things with the same bases we'll put next to each other. Y to the 1/3, y to the 1/4. And then that's going to be x to the 1/2 plus 1/5 times y to the 1/3 plus 1/4. We don't add the other ones to each other because they're different bases. Only the ones with the same bases can be added. So if you go through this, this would be 5/10, 2/10, 7/10, y to the 7/12, and that's going to be the 10th root of x to the 7 times the 12th root of y to the 7. Or, for this problem only, there's kind of a neato way of writing it. We could write this one as, nope, that's not going to work. It's not going to work. What we could do, the neato way of writing it, would be the 10th root of x times the 12th root of y all to the 7. That's a semi-neato way of writing it. Okay. Example 16. X to the 4 root w over w root x. This root w over w thing, that actually is going to come up a lot, especially next year when you do calculus and stuff like that. So that's going to be x to the 4, w to the 1/2 over w to the 1, and I'm putting it there, x to the 1/2, which we would write as x to the 4. I'm going to line them up vertically. When you multiply, the order doesn't really matter. W to the 1/2, w to the 1, which is going to be equal to x to the 4 minus 1/2 and w to the 1/2 minus 1, which is, in 4 minus 1/2 is 3/2. Whoops, there was that wrong way. Which is x to the 8 over 2 minus 1/2, 7/2. W to the n1/2 minus 1 is negative 1/2. We're not quite done. We have to turn this into radical notation. So x to the 7/2, w to the negative 1/2 is going to be, actually first we're going to deal with the negative. So w to the negative 1/2 is like that goes to the bottom, w to the half, which we could then write as, and we'll take our almost done color out here. And so the almost done color says that's equal to the square root of x to the 7 over the square root of w, or the square root of x to the 7 over w. And that would be the answer to that one. Okay. So what we have here is the square root of x cubed y to the 6th. And the way we're going to solve that one, or simplify that one rather, I'm going to write it first as an exponential notation. That's going to be to the half. When you have a power to the power, they multiply. That's going to be x to the 3 to the half, and y to the 6 to the half, which is going to be x to the 3 over 2. And 6 times a half is just y to the 3. And we can now write this in a pretty way. The square root of x cubed times y cubed. And there you go. Or usually since we put root things last, this one would probably be better to write as y cubed root x cubed.